Hello students, we have already studied structures in the previous video and I'll further explain and clarify the concepts. So let us have a quick brush up of what we learned so far. The steps involved in using the structures are: first we define a structure, that is the data members of the structure and the function members of the structure. Now, defining a structure actually means defining a record. We are defining the structure of our record and how our record should look like, and that structure will be shared by all the variables of that structure. Now, the definition of the structure involves two important things. One is data members and function members, as you already know. Data members can be of following types, that is, they can be primitive data type or derived data types such as arrays and pointers, or they can be user defined data types. So far we have only incorporated two of these, that is primitive data type of data members and derived data type of data members, and we have also included a function member. Now, after defining the structure, what is the second step? That is declaring the structure variable. And this step is important for allocating the memory for the structure variables. And when we define the structure, it seems that we are declaring the variables inside the structure, but it's not like that. It is simply defining the format of a record. Now, once we declare the structure variables, this is where the memory is allocated to the structure variables. You must be now knowing that what is allocating in memory. And it is allocated, once we create a structure variable, it is allocated for all the members of the structure depending on their data types and their sizes. Now, after that, the memory has been once allocated. The next step is accessing the structures as per our programming requirements. We can input the structure variables, or we can display the structure variables, or we can perform different operations on structure variables depending on their data types. Just like we did with primitive and derived data types, we know how to handle primitive data types, that is variables of the type character, int, float and double. And we know how to handle derived data types, particularly arrays. We have already learned that in previous videos. Now, user defined data type, we have not yet put the members of that type in the structures, and maybe today we'll put the members of user defined data type in structures. Now, by now, in the previous lecture about structures, I told you structures are user defined data types. Today we'll have some more clarifications on this so that it becomes clear what are user defined data types. Now, after performing these three steps, we should be comfortable with using structures and writing the programs on these what we call structures. Next, structure is said to be a user defined data type or a template or abstract data type. Let me explain this term to you. Now, we know what is a data type, and we know we declare variables of a particular data type using a declarative statements. In declarative statements, we give the data type and we give the variable name. For example, if I have to create an integer, I have to write int a. Of course, I have to write int in small case, and a is the variable name. Now, what this statement is not as simple as it seems to be. It has got a lot of meaning so far as C programming is concerned and computer science is concerned. Now, when I write int a, some of the clarifications I have already made. A memory location is allocated, and the name of that location is given as a, and a is bound to the address of the location, because so far as a memory location is concerned, it is a hardware device. It has got set of flip-flops and it has got address. Each location has got a particular address. So now a will be bound to a particular address, and that address or that location will be reserved for a, and that location we can refer with the name a. This is one of the meanings of the statement int a. Then whatever are the properties of int, they are inherited by the a. By that we mean int is defined as a data type which will allow the variable to store the integers, and integer operations can be performed on it, and it will have a size of 2 bytes and lot of other things. Here simply I want to convey that the properties of the int data type are inherited by a. This name is given by the programmer. It does not exist in the C language. This is called a variable name. So this a will now inherit the properties of the integer data type, and now onwards whenever you will be using a in your program, it will abide by the rules of the integers. That is, it can only store the numbers without the decimal points, and all the integer arithmetic operations can be performed on it. Okay, so a is inheriting the properties of an integer. Now what is integer? It is a basic data type available in C. There are 4 basic data types available in C. One is character, one is integer, one is float, and one is double. Now once we declare a variable of a particular data type, that variable inherits the properties of that data type. So that data type serves as a template. What do you mean by template? Suppose I have to make an elephant of wax. I will take a vessel, say iron vessel, which will have a shape of elephant. Then I malt my wax and put it into that vessel, and once the wax solidifies, it will take the shape of that vessel, and of course I have told that shape of that vessel is of the shape of elephant. So that vessel serves as a template. This is what we mean by template. And templates are used in industries. Suppose you have to manufacture certain parts. You have already got the vessels of shape of those parts, and you molten the iron and put into those vessels, and the iron, once it solidifies, it takes the shape of that vessel. This is what is meant by the template in the real world. Now here your template is integer or character or float or double. Once you put a into integer, it is something like that. A will assume the properties of the integer. Now a is some variable name that is given by the programmer. So that variable accepts or it inherits the properties of the integer. Before that, now if I use the same location can be used for storing characters, but in that case the data type will be character. So whatever is the data type of a variable, it assumes the properties of that variable. That is why I can say integer is a template. Now integer is a data type, integer is a template, or integer is an abstract data type. Okay, but integer is a compiler defined data type. I have not used a word here. It's a compiler defined data type. So where from I got the integer? It is already available in the compiler. This keyword is already available in the compiler. I use the keyword integer, then variable name I gave myself, then that variable assumed the properties of the integer. In other words, integer served as a template, as if a was put into this template, and a assumed the properties of this template. That is why we call a data type as a template. Okay, any data type can be called as a template, because once we declare variables of that data type, it assumes the properties of that data type, and that data type is that variable is basically a memory location. Now memory location has assumed the properties of integer. Otherwise memory location can be used to store anything, integers, numbers, variables, characters. But once you bind that memory location with a declarative statement to a integer, to a name, and that name has been declared with a data type, say in this example as an integer, it will assume the properties of the integer. So this data type will serve as a template. Okay. Same is the case with what we call as abstract data type. Abstract data type means it is a mathematical model. Now, what is a mathematical model? Mathematical model is, suppose we have got integers. There are operations like addition, multiplication, division, and subtraction. They are defined on the integers. Once that model is created, so if we have the concept of integer data type, and that integer data type has been defined in the mathematics, and the operations have been defined in the mathematics, and now if I say A is of type integer, so A has got the properties of that model. So this data type serves as abstract data type. By abstract data type we mean it is a mathematical model. Now it is a mathematical model, and that model has put its influence on A and put its attributes on A. So A has got all the attributes of the integer as have been defined in a programming language. It will be up to that extent only. Now in C, I told you integer by integer does not lead to a decimal value. Okay, this is a limitation of this model. Okay, now I can say data type is a template, or it's an abstract data type. In other words, it's a model. And once we have got a variable of type A, it assumes the properties of the model integer. Okay, this is clear. Now if I have got a struct student S1, initially I define the structure. This is the second step where we create variables of type structure. If you don't understand here, you should see my first video lecture on structures. You'll get an idea what I'm saying. So if I declare a variable of name S1, there are two ways of actually doing it. One is you use a keyword struct student and declare a variable S1, or you only use student and S1. Now if I say student is a user defined data type, actually this is a misnomer. They should not have called it as a user defined data type, because it is not user who is defining the data type. It is the programmer who is defining this data type. It is a programmer who is submitting the definition of the student to the compiler and telling or informing the compiler that I need a data type, new data type of type student, and it should be collection of following heterogeneous members, because structures are collection of heterogeneous members. They can contain members of primitive data type or basic data type or compiler defined data type. This is one and the same, basic or compiler or primitive data type. This is one and the same, and these are four types as I have made clear, that is character, integer, float and double. Or structure can have arrays. Now arrays are not primitive data type, they are called as derived data type, because they are collection of variables with the same group name. So structure can contain arrays, that is derived data types, or it can contain members of type primitive data type, or it can contain the members of user defined data type. I told you student is a data type. See how we can justify that student is a data type, because S1 assumes all the properties that you have defined in the student, and therefore student is a user defined data type. S1 assumes all the properties of a student, therefore student is a template. S1 assumes all the properties of this model student, so S1 is a student is a abstract data type. So student is a data type, student is a user defined data type, student is a template, and student is a abstract data type. You can see this now. But I told you, if I would have written a book, I would not have called it as a user defined data type, I would have called it as a programmer defined data type, because the definition of the student is put forward by the programmer and submitted to the compiler with a request to the compiler that I need a data type which is the combination of following members, and I specify the what you call the data type of those members. I told you the members of the structure can be of type primitive data type or derived data type or user defined data type. Let us see this in a compiler and let me explain it to you here. If I declare a variable of type int a, as I have cleared, int is now a model and a assumes all the properties of this model. Okay, that is, a behaves like an integer. It is actually a memory location. It has now got properties of a model integer, and all the operations of the integers can be done on it based on the model that C compiler designers have created. Okay, now if I define a structure, say struct, this is how we define it. First we use a keyword struct, then we give the name of a structure. Suppose I give student. Let me only keep two members in this student. Okay, one is char name, okay, of 30 characters. Now this member I am defining as a character array. Okay, and another member, say 8 roll number. Okay, let us have one more member, say suppose int total marks. Marks here is opted marks. Okay, now the first member is the name of a student, second member is a roll number, and I am defining the structure of my record. I have not created a record. Okay, you should have a terminator here. So once the structure is defined, first you use a keyword struct, then you give the name of a structure, then you give data members and function members. Okay, let me have one more function in this. Now this function, since I am writing within the definition of the structure, that is within the curly braces, these two curly braces, and therefore it belongs to the structure. I will call this function as a message. Okay, this message, I am simply using this function to, I will say, no, I will use now cout, say hello. Okay, since now this function is a part of a structure definition, therefore this function does not have an individual existence. It exists within the definition of the structure. So this function cannot be called, okay, independently with its name. Okay, once we have created the structure definition, the next step is creating the structure variables. Okay, I can now say struct student. This is my data type. I will say S1. Now S1 is a variable of type struct student. So struct student is my data type. Actually the data type is student. Struct is a keyword. So I told you there are two ways of creating variables. One is you can use a struct keyword, or you cannot use. You will say now student S2. Okay, I have created two variables. This is a clear-cut indication, the second statement, that I have created a student S2 which assumes the properties of the student. And what are the properties of the student? The properties of the students are the data members and the function that is within this structure. So now S2 will have one member as name, one member as roll number, one member as marks, these are the data members, and one member as a message, and that message is a function. So structure has two types of members, one is data members and one is function. Okay, now let us compare this statement with this. In this statement I have declared int a, that is basic statement, declarative statement available in my programming language, and again now I have created a structure student, and after defining the structure I have created a variable S1 and S2. Now S1 is getting the properties of the student. How is it getting? Because now we will have, once we declare S1, we will have three variables created: name, roll number and marks for S1, and a message for S1. Same way we will have three members for what you call S2, that is name data members, name, roll number and marks for S2. They will be different from S1, and message for S2. Okay, so S1 has got the properties of the student. Now these members basically have the properties of their respective data types. Now if name, it is a character, so if S1 dot name is a member of S1 but still its data type will be character. Okay, so we have got one array has been created, one integer roll number has been created. If we have S1 dot roll number, so one roll number has been created for this S1. Okay, and marks have been created for S1. So actually how many variables are being created? One array has been created and two integer variables have been created, and a function has been created. Okay, now functions are basically created only once. Okay, so all the structure variables will be sharing these functions. Okay, but data members will be created separately for each member. So you can take it that data members are created for each variable separately, and function members are created what you call once only, and all the copy of these members will be shared by all the structured, so all the structured variables will be sharing this copy. Okay, now I think it's clear now. As the integer a or a location has assumed the properties of the integer, okay, same way S1 and S2 have assumed the properties of the student. What are the properties of the student? That it has got three members, so S1 will be having three members, and now memory is allocated in once we declare the variables of structure. Okay, so my point here is student is a data type, student is a template, and student is an abstract data type. Since this data type is created by the programmer, so we call it as a user defined data type, and user defined data type is usually the combination of primitive, derived and other user defined data types. So this is the broader definition. Okay, but once we see derived or the user defined data types, again they will be again the holding the properties of the primitive data type. So we say the student actually is a user defined data type that is constructed from primitive data type, even though it has the members of derived data type and what you call other user defined data types. Let us see that later. Okay, I think this much it is clear. Okay, now as I have told you, we have compared the two statements, int a and student S1. A assumes the properties of the integer and S1 assumes the property of the student, but these properties are created by the programmer, and the programmer has defined the structure of the student, and S1 has assumed the structure or the definition of the student. Okay, so student is a data type, and each time we create a structure, it is a different data type. Now if I create second structure of type employee, suppose I create a second structure, let me create a second structure so that you understand it. Okay, now let me create another structure, say struct struct struct. I call it as a date. Okay, it has got three members. Okay, int day, that stores the day of the date, because we don't have a date data type in C. So int day, then we have got a month. Okay, now int, and we have got a year. Now this structure, day is a different data type, sorry, date is a different data type. Date is a different data type and student is a different data type. Date has got three members, that is day, month and year, and student has got three members, that is name, roll number and marks. Once I create a variables of type date, that will have the three members, that is day, month and year. So that variable will assume the properties of the date, and if I create the variable of type student, that variable will have the properties of a student. Is it clear? So I can create more than one data type. This is my point here. It is so user can create as many data types as he wants. The data type here is the name of a structure, that is date, and the name of the structure, that is student. And now we can create, the first step is always defining a structure. Second step is creating the variables of type date. I can create a variable of type date. How do I do it? Simple. I say date and then I create a variable, say x. Now x is of type date, okay? So it assumes the properties of the date. So x has got three members, x dot day, x dot month, and x dot year, okay? So x has assumed the properties of the date. So date serves as a user defined data type or template or abstract data type. You will be seeing these terms in the books on C++, that is abstract data type or user defined data type or what you call as template. Now second is the compiler defined data type. Even that data type serves as a template or an abstract data type, but that data type is not created by us. That data type is provided by the compiler. So user defined data type is created by the programmer, and the primitive data type or basic data type or compiler data defined data type is already available within our compiler. This is my point. Okay, now let us go back. Now once we have understood what is a user defined data type, what is a template, and what's the abstract data type, now onwards I will be calling the structure as a user defined data type or template or abstract data type. You should not be confused with that statement, and I have told you it is same as the declarative statement. That is where you give the data type first, then you give the name of a variable. For primitive data types, the rule is data type and the name of variable, that is int a, okay? Then we can also initialize it, that we'll see later. Okay, now let's go for the next. Initialization of the structure variable at the point of declaration. Now we can initialize the structure variables at the point of declaration. Yes, it is possible. Let us see how we do it, and let us do it practically so that we can understand this. Okay. Okay, if I have defined x as a variable of type date, let me first, okay, let me do it. Now since it has got three members, so the first member is a day. How do I initialize the integer? I give a value of the day, okay, that is 12th. Now I give a value of a month next, separated by commas, that is 1, since it's again an integer. So third member is there. So member values are separated by commas. The first member is the day, I give the value. Next member is a month, I give the value. Now third member is a year, I give the value, suppose 1940. Okay, this is initialization at the point of declaration. Let us compile it and see if it works. Oh, there are errors. Let us undefined symbol say out. So we know that we have to include hash include what you called IO frame dot h. Okay, now it will work. Okay, Control F. So it's not giving me errors. So whatever I have written is a valid code. I have created two structures. One is the date and one is the student. So I have created two data types. One is the date and one is the student. And in this example, I have shown how we create a variable of type date. We give the data type, that is date, then we give the name of variable. This is how we do for primitive data types also. We give the data type, suppose int, then we give the name of a variable, and then we give the initial value if you want to initialize that at a point of the declaration. The same thing we can do for user defined data types. Now if I will create a variable of type student s1, I have to give values to it. Now see how we give values. We start with first member. First member is the name, and since name is an array, the way we initialize the arrays, same method can be employed here. Since I have shown in, if you see character arrays, there are two ways of initializing it. One is giving the individual elements and then storing a /0 at the end, or using the double quotes and give the string value in that, and that's the easier method. I'll be using that only. So I say the name of the student as the roof. Okay, so this is the first member. Since it's an array, so I am initializing it accordingly. The way you initialize the primitive data types, same way you initialize the or derived data types, same way you initialize the members of a what you call structure. Okay, now next member is the roll number, so it's an integer, it can be 12. Okay, now next number is the marks, total marks. I can give, suppose he has got 450 marks. Okay, I have initialized all the three members. Let us see if my compilation works. Or see, I compile and compilation is working. So this initialization is valid. Otherwise, there were errors, would have been errors. Now, I have created two structure variables. One is the X, and I have given the initial values to day, month, and year. And I have created another structure variable, that is S1, and I have initialized it. And I have created another structure variable, that is S2 of type student. I have not initialized it. So it is the what you call choice of a programmer, whether he will initialize it or he will not initialize it, depends on his requirements. And we have seen the default values that a structure will assume once we leave it uninitialized. Let us debug and watch and see what are the default values of. Now I can watch S1. Okay, I can watch Alt-D. I can watch S2, which is uninitialized, and I can watch Alt-D, that is X, which has been initialized. Let us do it now here. See, first main. Now see, S1 is initialized. The first member has been initialized. That is here S1, which I have created of the type student. The first member name is holding the value roof. The second value it is holding is the value of a roll number 12. And if you see S2, which was uninitialized, you see the integers have got value 0, and the character array has got a null value. This I have already clarified, that if we don't initialize the structure variables, the characters are initialized to nulls, strings are initialized to nulls, and integers, doubles, and floats are by default initialized to zeros. These values are given by the compiler, therefore I called these values, we call these values as default values. These values are not given by the programmer. So whenever you create a structure variable, and if you have got integer variables in them and you have left them uninitialized, you will get a 0 value for that. Same is true of double, and same is true of float. Okay, and for character arrays, if you leave them uninitialized, you get something like null characters. Okay, let me only give two initial values. Okay, is it possible? Let us see. All see, we compile it. Okay, compilation is a success. So you can give lesser number of members in initialization. Since this student had 3 members, I have given only 2 initial values. So lesser number of initializations is allowed. Let us see this after this, but I will give more than 3 members. Let us see what happens. All see, we'll compile it as an error. Yes, you cannot give more number of members. This was true of arrays also. So you can give lesser initializations, that you can initialize only few data members, and you can leave others uninitialized. But you can give initial values for all the values, also for a particular structure variable. I think this is clear now. Let us give lesser number of values and see what happens in this case. This is here. Okay, so in this case I give the initial value. The first value is given to the name, and second value is given to the roll number. The third value, that is marks, which was uninitialized, it assumed the default value 0. This is here clear here. S1, you can see first member has a roof, second member has a value 12, and third member has 0, because I have left third member as uninitialized. So initialization can be done for all the members or for some of the members, but you have, the moment you start your initial values, you have to start from the beginning. Okay, not from the end. Okay, then you can give values, initial values for first few members. They should be in the sequence, and rest of them you can leave uninitialized. Okay, this is clear now. Now let us see this now. Next step. I hope this is clear now. Okay, so this is initialization of a structure variable at the point of declaration. We can initialize structure variables at the point of declaration by giving initial values to all the structure variables, but we should see what are their data types. If they are simple primitive variables, we can give their values, but if they are arrays, we have to give set of values. Okay, I think it's clear. I think I'll have one more thing here, and that will be better if I do it like that. Now see here, if I add one more member here, that is or I will change this, I'll add it as an array of three subjects I'll be entering. Okay, so now if you see initialization here, the first thing we have initialized is the name, second thing we have initialized is the roll number. Now third member is an array of 3 elements. So first member is initialized like this. I told you the initial member values of the members are given, but they should be separated by commas, and the members should be initialized according to their data types. Now marks is an array. It is not a symbol variable. It is not a single variable that will be having one value. This is an array of 3 elements, so we have to give 3 values. How do you initialize the integer array? I have already shown, and same method we will use here. We'll put a brace, then we will give 3 values. We can give 12 suppose for one element, 23 for the third element, and 56 for the next element. This is how we initialize the integer arrays, because I had not taken this example, so it will be clear. Now you can see here. Now the first member is the roof, second member is roll number, that is the name. First member is the name, sorry, second member is the roll number, third member is the marks, and now marks I have kept for 3 subjects, so it's the array of 3 elements, so I have given 3 values. So S1 will be having these values, but S2 I have not initialized. So first member is a null, second member is 0 because the integer. Now third member is an integer array, and each element of this array is an integer, so it has been initialized to 0. As I told you, initial values of integers are 0. For date I had given these values to the 3 members, initial values, and it has assumed those values. Now X was the variable of type date. Okay, F2. Okay. Now that, let us go to the next slide. Now copy one structure variable into another. For primitive data types, it is possible to assign the one variable into another. We have been using this in assignment statements. That is, if we have 2 variables of the primitive of type integer, we would say variable 1 is equal to variable 2. And what happens because of that? The contents of variable 2 are copied into variable 1. So it copies the contents of variable 2 into variable 1. The data type should be compatible. Can we do this for the structure? Let us see in the example itself. Okay. Now let us see in the program itself. Now see here, if I have got 2 integer variables, that is a and b, I'll say a is equal to 90, then I declare another variable b. I can now say variable 1 is equal to variable 2, that is b is equal to a. Okay. If I say b equal to a, what will happen? The value of a will be copied into b. This we have done, and this is clear. Let us watch it. Alt D, and we watch b. Okay, and if I say F7, now you see this is the primitive data type A and primitive data type B, or basic data type, or compiler defined data type, and this assignment statement is equally good for them, and it works. And see here, if b is equal to a, initially b is having junk value. Now after this statement is executed, b is having value 10. You can see in the watch window, b is now having value 90. Sorry, b is having value 90. Why 90? Because a was 90. Okay, so once you assign one variable to another variable, the contents of the variable on RHS side of the assignment are copied into contents of the variable in the LHS. And this is same, this we have discussed in now far, and we have used such statements. There will be no problem in using such statements. Now if I have got 2 structured variables, and 2 structured variables, say S1 and S2, and S2 is of type student and S1 is also of type student, that is, their types are compatible. Now if you see the another variable, say here x has a type date, okay, but S1 is of type student, so they are not compatible. Let us see what happens if we write something like this. If I say S2 is equal to S1, what will happen because of this? Let us see. Okay, I use F7. Okay, now what happens first? The variables have been already created, S1 and S2. S1 has got these initial values. You please watch this watch window and you will understand. S2 I have given these initial values. I have not given this I left uninitialized, so it is the default values. Now S1 is having these values for its members. For name it is having the value roof, for roll number it is having the value 12, and for marks it is having the 3 values for the 3 subjects. But for the S2 everything is 0 and null. Okay, now let us see once this statement b is equal to a, we saw once we say b equal to a, b assume the value 90. See watch window. Now let us see what is the effect of this when if we say S1 is equal to S2. Now see here what has happened. If you see S2, all the members of S2 have received the values which are the corresponding values of the members of S1. Is it clear? So if you want to copy one record into another record, or you want to copy one structure variable into another structure variable, you have to simply write an assignment statement. It's a wonderful statement, a very powerful statement. S2 is equal to S1, and so we can assign one user defined data type into another user defined data type, provided their variable of one user defined data type into variable of another user defined data type, provided their value data types are compatible. Note, the data type of S1 and S2 is student, and data type of B and A is integer. Let us see what happens if we do it for those data types which are not compatible. Okay, if I say now, you have learned this, you should remember this. If you want to copy one structure variable into another structure variable, you have to simply assign one variable into another variable, and the variable on the RHS, it's whatever all the values of its data members, they will be copied to the corresponding members of the variable on the LHS, provided the two variables have same data type. Now, if we have got something like this, if I put this S2 is equal to X, now S2 is of type student and X is of type what you call another data type, that is date. Let us see whether it works or not. This leads to errors. Let us see the error. Cannot convert date into student. Yes, you cannot do it if two variables are of having dissimilar data types. Now X is of type date. If you see here, X is of type date, X is of type date, and what you call this S1 or S2 is of type student. So you cannot copy, it's not possible. Also, see that data type has different members and this data type has different members, so you cannot assign two incompatible data types to each other. But this is possible in C++. Later on we can see, once we see data conversions. That is a bit advanced topic at this level. You need to go with preliminary lectures first, then we can see what is data conversion, how we achieve it, how we convert the object of one data type into another data type. That's a bit advanced. Or how we convert the variable, student variable of one data type into another variable of different data type, and we can do these assignments. In that case, we have to do some programming techniques we have to use, and the statements like S2 is equal to X will be possible. Okay, now let us go back and see what is happening next. Okay, so we have seen that if we want to copy one structure into another structure, it is possible. Simply say structure 1 is equal to structure 2. The members of the structure 2 will be copied into structure 1, and but the important condition here is the two structure variables should be of same data type. That is, they should have been created out of the same definition. Their definition should be same. Okay, or their template should be same, or their abstract data type should be same. Okay, next. Now, how do we access structure members? Let us see that first, and then you can understand. Accessing a data member means, I have already discussed in my previous lecture that I have uploaded, what is accessing a structure member mean, or what accessing a memory location means. Accessing a structure member means that you can input it from the keyboard, or you can display the contents of that member onto the screen, onto the user screen, or you can use it in the assignment statement. Okay, this means accessing a structure variable. Okay, I have to do a bit of explanations here also, and you can see that. Now I have got suppose first structure variable S1. Suppose I want to access its roll number. I will say now, suppose I will say, you know how to access. First we give the name of the structure variable, then we give the name of a, followed by dot operator. This is called as a member access operator. Then we give the name of a member, that is roll number, that is S1 dot roll number. Roll number, what is the name we have given? Yes, S1 dot roll number. We have to give the same name as we have given in the definition, equal to 40. Since I am using it in an assignment statement, this is accessing the member. Actually, I am writing onto this memory location, which is named now as S1 dot roll number. Okay, now let us see what happens. Is it accessible or not? Yes. Now if you see S1, it is having for roll number, its value is 12. Let us see that if that changes after this statement to 40. If you see there is a change here and it is to 40, that means you have written onto this memory location, that is S1 dot roll number. So actually, how many memory locations have been created? The character array has been created of 30 elements for S1, and a roll number has been created for single location for S1, and marks of 3 locations for S1. Okay, because marks is an array. Okay, now this is we access. We can even see in this, see in what is called S1 dot roll number. This is inputting it from the keyboard. This should work. Then I can see out s1 dot roll. No. These are all now C++ programs, since I'm using C in and C out, and the extension of the file is .cpp. If you see at the top, the programs that I'll be creating for C, I'll be saving them as .c extension. C files have .c extension, and C++ files have extension CPP. This is CPP stands for C++, and this is how we differentiate between C files and C++ files. Then all the features, object-oriented features, are available in C++ files, and the features of C, they are limited as compared to C++. Okay, now if we have this, this means I'm using it in an assignment statement, or I'm using a member in an assignment statement, or I'm inputting the member, or I'm displaying the member, and this will clearly indicate that you can, this is allowed. Now where I am accessing these members, if you see, I am accessing these members within the body of a main. Okay, I cannot write C in or C out outside any function. We cannot write, only one type of the statements can be written outside the functions, outside the body of a function. That is the declarative statement. If I write something like this, s1 dot roll number, this is outside the main, because the body of main starts from here, and this is the structured definition, okay, for student, and this is the structured definition for date. Okay, now can I write C in C out, that is can I write input output statements or assignment statements or conditional statements or loops, that is iterative statements, out of the function body? No, it's not possible. See, suppose I am writing an assignment statement here, and this assignment statement is now out of the function body. It does not lie within the body of any function. Let us see if this works. See, there are errors. What is the error? Variable declaration syntax error. So this is not possible. This is not possible. So you can write what you call input output statements, conditional statements, iterative statements only within the function body. Also, this is also true of unconditional statements. Only statements that can be written out of the function body are declarative statements. You should remember this. Out of the statements that are available in C or C++, only declarative statements can be written out of the function body, outside the function body. No other statement in C or C++ can be written outside the function body. That is, what are the statements? That is the assignment statement, input output statement, conditional statements, iterative statements. Okay, let me try. Suppose I write C out S1 C out, sorry, we have to use this operator, C out S1 dot roll number. Okay, now if I compile it, see, there will be error. What is the error? Type mismatch in redeclaration of C out. This is not allowed, because this statement, that is input output statement, was outside, written outside the body of a function. So where I am accessing my data members of a structure, I am accessing within the main. Accessing means using them in an assignment statement, or for in input output statements, or within loops or conditional statements. This is possible only when these statements lie within the main or any other function. We cannot write assignment statements, input output statements, conditional statements, iterative statements, unconditional statements outside the body of any function. Only thing, that is only statement that is possible to be written outside the body of any function is the declarative statement. This is the only statement available in C and C++ that can be written outside the body of any function. Okay, that means it needs not to be written within the body of a function. And once we do like that, the declarative statements outside the body of a function, as I've already told, are used to declare the global variables, and the declarative statements that are used within the body of a function are used to declare the local variables for that particular function. Okay, now let us see what we are trying to do in main. We have written the assignment statement and two statements. What are the input output statements within the main, and in these three statements we are accessing the data member of a structure variable s1, and since I compile, I'm not getting an error, so it means I can access it. There is no problem. Okay, now if I do it again, now if you see s1 dot roll number, it should come, close this and see here, s1 dot roll number is 40 now. It was initially 12. Since it was assigned 40, now it has changed to 40. Let us input it and see if it changes again. Okay, since I give the value 78, now if you see, the roll number is now 78. That means I have written on to that location that was s1 dot roll number. S1 dot roll number is nothing but a variable, but this variable has now fixation with s1. Okay, and so the name of this location is s1 dot roll number. If I say cout s1 dot roll number, let us see that works also or not. And if you see, it has been displayed on the screen, so we can access the data member of a particular function. Okay, now let us try to access its we can access the data member of a particular variable. Okay, structure variable. Now what was meant by accessing the structure members? Accessing a data member means using it in the input, output, or assignment statement. For basic data types, how do we access? We use structure variable dot data member name. This we have done already. Since roll number is an integer data type, so we use structure variable dot data member name. This is a fully qualified name of that particular variable, since now it belongs to a particular structure. Now for arrays of type int, float, and double, we have to give something more, that is index. Okay, and for arrays of type character, we have to give index if we want to individually access it, that is structure variable dot array name and index. And then if we use it in gets and puts, since in gets and puts we give only array name, so we can give structure variable dot array name. Okay, this we have already done. Now for functions, accessing a function means calling a function or using a function, and I was basically talking about, we were talking about accessing structure members. Now structure members are of basically two types. One is the data member and one is a function member. We discussed about data members and I showed you how to access a data member of particularly primitive data type, and then we will see for functions. Accessing a function means what you call calling a function or using a function. Basically I have already uploaded a video on accessing a what you call a memory or a structure variable. You can see that, and this is basically, I'm assuming that you have watched that video, and based on that I'm simply giving a quick brush up and adding some more concepts to the concept that I've already discussed. Okay, now let us see here how we can access a function. Okay, now if you see this structure student, it has got three data members and it has got a function inside its body, that is within this definition. This is now member of this structure. I cannot call message directly because it does not have the individual existence. It is because it is defined within the structure. Okay, now since it is defined with the structure, now let us see how we call this function. If I would have called the message, I would have said message. Since it does not have any arguments, so no argument would have been passed, and since it does not anything, it would does not return anything, it would not have been assigned to anything. So I will say s1 dot message. If I call message only, you see what happens. There is an error. What is the error? Function message should have a prototype. You will get an error here. So you need not to do something like this. It is not allowed. So you cannot call function like this. You have to use s1 dot message and then put a terminator. You have to put it terminator also. I had missed it, but you cannot call message directly with its name. You have to qualify the name with the name of a structure variable. Okay, now we can see whether function call is possible or not. Calling a function means using a function. Okay, or accessing a function. Okay, this is one and the same thing. Accessing a function means calling a function. Is it possible to call a function that has been defined within a structure? This is our issue. Okay, So if you see here now, this function is called, okay, it will display a message hello on the screen, and terminate. If you see it, it has displayed hello on the screen. Since this function was a part of the structure, so we could what you call could not call it simply by specifying its name only. The name of the function is message. We have to use a structure variable to call this function, that is s1 dot message. Okay, I hope this is clear now. So we have seen how we access the structure members, how we access a function within a structure. Now it is clear now, within the structure we will have data members and function members, and this property is called as data encapsulation. Data encapsulation means that within the structure you will have two types of things, that is the function members and data members, not only data members. So this is called as what you call as data encapsulation. Now let us go ahead. Now important issue after discussing that we can access the data members of a structure is it possible to restrict the access or visibility? Access is also called as visibility of a data and function members of a structure. Okay, is it possible? Let us go here and see here what I mean by that. Now see, within the main I can access two things, that is s1 dot roll number equal to say 67. So I am accessing two things, that is one is the roll number of s1 and a message of s1. Okay, it is possible. How it is possible? Because once I compile it, there will be no errors. There will be no errors. So since there are no errors, warning does not matter. What matters is errors. So these two statements are allowed. I am accessing the roll number. How I am accessing? I am changing its value to 67. So I am writing into that location. Now I am accessing a message. So what I am doing, I am calling this function which was the part of structure. Now is it possible that I can restrict the access of these members, data members and function members of a structure? Yes, it is possible. What you have to do, you have to write a word private or protected at the top. Now if you write private or protected at the top, let us see what happens. Or see, I compile and see what happens. There's an error. What is the error? Student roll number is not accessible. Student message is not accessible. How has that happened? How has the access been restricted? Okay, the access has been restricted by putting this keyword, that is private. Okay, the default access or visibility of the members of a structure is public. Public means any function can access the members of a structure. Okay, once I make, now which function was accessing the members of a structure? Main was accessing. So because I told you accessing can be only done within a function, because assignment statements, input output statements can be written only within a function. Okay, we cannot write these two statements outside the function. Now the main was accessing the members because these two statements were written in the body of main. Okay, once the main was accessing these members, but once I made them private. How? By using a keyword private and a colon. The access to these members was restricted. If I use another keyword called as private or protected, there is another keyword called protected. This also changes the visibility or access of these members. Now they won't be accessible. Now, so if we make member as a private or protected, it is not accessible. That means you cannot input it, you cannot output it, or you cannot use it in the assignment statement, either LHS or RHS. Okay, once that is clear, that means the access has been restricted. Okay, this is something called as data hiding. So how we hide the data? We use access specifiers, private and protected. Once it is accessible, what is the access specifier at that time? It has a default value of public, public. If I make it public, which it actually is by default, all the structures by default, their members are public. Okay, if I see public, if you see now, if I compile, there won't be any errors. Okay, Once I made it private or protected, the main was not able to access the data members and function members of this particular structure. If you use the word private or protected, so how have we restricted the access? By using a keyword private or protected. What is the default access to the members of the structure? The default access to the members of the structure is what we call as public. This is clear now. Public means any function can access the data members or function members of that particular structure. Okay, I hope it's clear. So it is possible to restrict the access or visibility of data and function members of a structure. How? By using the access specifiers. Visibility is of three types: what, private, and protected. If you use these two access specifiers, the data and the function members of a particular structure cannot be accessed. And if you use a public specifier, then you can access. The default access of all the data and function members in a structure is public. How do you know that? Because you did not write public, or you did not write public there. You are able to access it still. So default access, you could access, you have seen that any function could access the data members and function members of the structure. So the access was public. Once you made the access specifier as what you call protected or private, then what happened in that case? The access was limited. Okay, now let us go into another topic, that is declaring a structure variable of a particular type in another structure of a different type. Okay, there are two ways of doing structure whose variable is declared in the another structure variable and is defined within the same structure. Okay, that is, we define the structure within the same structure and then we declare a variable of that structure within the same structure. Second way is that we define the structure outside the another structure and then we create a variable of that structure within that structure. Let us see both the methods and it will be clear. Okay, so see here. So if I have a structure student, let me remove this visualization. Okay. Unwanted parts I will remove so that it will clear what I am doing actually. So this is what I have explained. Now we have a structure of type date and we have a structure of type student. Can we declare a variable of type date within the student? Yes, it is possible. How? We use the data type, that is date, and we give the variable name, so suppose d. Now d is a variable of type date which is itself a user defined data type. So we can have a member of user defined data type within the structure. Let me compile first and see if it allows. Okay, it is allowed that I can create a structure variable. I can declare a structure variable of different type in a structure of another type. It is possible. Okay, so I have declared a variable d of type date. Now student has got four members. One is date and one is character, array, that is name, and an integer, roll number and marks. Let us access d. How we access the d? With s1. Now since d is a member of the structure, we have to first give the name of the structure, that is s1. Now another member is d, and d has got how many parts? It has got 3 parts, that is day, month and year. So we can access each part separately, that is d dot date equal to, suppose, is it date or day? I have used, should be day. It is day, month and year. Okay, I give day equal to 1. Okay, now first we give the name of the structure variable, then we give the name of the structure variable which is declared within the variable, then we give the name of a member, suppose month, and then we give a value. This is how we access it. Okay, now s1 dot day dot year is equal to say 1940. Okay, now let us see what happens because of this. Since we have created the structure s1 and s2, structure variable s1 and s2, we have left it uninitialized. Now s1 has got 4 members and s2 has also got 4 members. The first member is the d, which is of type date. The second member is the name, third member is the integer roll number, and fourth member is the array which holds the marks. Now let us see what happens because of these statements. Since s1, that is this structure, has got d, and d has got d as a member, and d has got 3 members, that is day, month and year, and then we can initialize those members. See, the day has been initialized to 1 and month has been initialized to 90 and year has been initialized to 1940. Okay, this is clear. So we can have a variable of type struct, that is we can have variable of another user defined data type in the structure. Okay, so it is possible. That is why it was possible to have a date d within the student. Okay, now d has got 3 parts, that is day, month and year. Now d does not have individual existence. It is simply in the definition we are saying that that we should have a date of type, we should have d of type date. Okay, date is the data type of new user defined data type. So we defined the structure variable. Why did we define it? We defined it outside a structure. Okay, it is possible that we would have defined it within the structure. Okay, that is here within the structure. Okay, we don't need a public keyword here because it's a default access. Now we can say struct struct date. This we are doing now within the structure. We are giving the definition of the date within the structure. Okay, now we can remove this definition. Okay, now in this case we have defined the structure within the structure and we are declaring a variable then within that structure. So we have defined the structure date within the structure student, and then we have created the variable. This is also possible. These are the two methods that we have shown you on the slides. That is first defining the structure outside the structure and declaring its variable within the structure. Now we have defined the structure within the structure and also declared the variable of that type within the structure. This is also possible, and the both possibilities can be used. Now what is the difference? That I'll tell you after this. Let us see compilation instructions. So you can equally define a structure within a structure and then declare its variable within that structure. Okay, so d is of type date and date has been defined within the structure student. The first case was when we defined the date outside the structure and then we were able to create its variable within the structure. Now see here, if I had another structure, what is the difference between the two? The difference is that now you can create the variables of type date within the student only. Within the student only. You cannot create them outside the student. That is, the variables of type date can be only created within the definition of the structure student. If I have got another structure, I cannot create the variables of this type. Let me show you. Suppose I have got struct A. I'll keep 2 members for it. This is simply to explain you what is the difference. Now I have defined A outside the structure student int B. Okay, now I create a variable of A. Let me call it as apple. This is the apple structure, apple data type. Now I created the variable of apple within the student. This is possible. I can say data type apple and J, it is possible. Alt C, compile, and you see it is possible. Let us try to create another structure. Now we have got three structures: struct, start, fin. Okay, this is a different structure because it is not defined. So first structure we have defined is apple. Next structure I have defined fin. Can I create a variable of type apple in fin? It is possible. Apple, say G. Now if I compile, there is error. Right? What is the error? Too many declarations. Oh, I have to give here terminator, because every structure definition should terminate with a terminator. Okay. Now don't forget to put a terminator at the end of the structure definition, because normally we have terminator, never have the terminator at the end of a curly brace. Okay. Now if you compile, it's a success. So I created a structure apple, then I created a variable of type apple in fin and in structure student, because apple was not defined within the fin and or within the student, it has been defined outside them. Okay. Now let us try to create the variable of type date within, let me write one more structure. I'll define one more structure. Structure fig. It has got two curly braces and a terminator. I create a variable of type apple here, apple h. Does it allow? Yes, it is allowed. So I can create an apple. Now let me try to create variable of type date within fig. Is it allowed? Date D. Okay. If I compile, there is a warning. Use qualified name of date. Okay. Actually, this is not allowed because you have to then do it in a different way. For that we have to use a scope resolution operator, otherwise date would be recognizable within the structure, and if you do it within C program, it will lead to errors. So if we declare a structure outside a structure, or sorry, if we define a structure outside a structure, you can create the variable of that structure in any structure. But if you define a structure within a structure, that is a nested structure, then you can create variables of that type within that structure only. Okay, this is the difference. Okay, we could create the variable of type apple within the student, because apple has been defined outside the student. But we can create variable of type date within the students only, because in C I'm talking, because the date has been defined within the student. Okay. Now let us go for next concept. Okay. This is what I mean by declaring a structure variable of a particular type in another structure of a different type. Then there are two ways of doing this. That is the structure whose variable is declared in another structure. That is, we used for this we use example date, and we created the definition of the date structure later on within the structure student. And or we can do it how the structure whose variable is declared in another structure is defined outside that also. For example, apple structure, we defined a apple structure outside the structure student, then we created its variable within the student structure. I hope it's clear. Next, now we have another concept, that is structure and class. Basically the two concepts are same so far as C++ is concerned, with slight difference. Let us class will have also is also a user defined data type. It is also a template, or it is an abstract data type. You create a class with a keyword. Whatever concepts we have discussed so far apply to class as well. Okay, so let us see the difference now. How do you create a class? You use a class keyword instead of a struct keyword. Then you get the name of a class, say say employee. Okay, then you give the members of that class. Okay, the way you did for structure, you can create any members, say char name of 40 characters. Okay, I will see your int EID, that is employee ID, which is a number I am putting this time, and I can put these two fields. This is sufficient to explain to you what is the concept of a class. I told you class is same that of a structure. In almost all the concepts that apply to structure apply to the class also, but with a slight difference. You create a structure with a keyword struct, but you create a class with a keyword class. So I use a class employee. Okay, the first step is always defining a class. Second step is declaring its variables. Now let me declare a variable of type employee. I will say employee E1. So E1 is of type employee. Okay, so employee is a data type, or user defined data type, or it is a template, or it is a abstract data type. You will see this definition in almost all the books. Class will be defined as abstract data type, or a template, or a user defined data type. Now it will have two types of members. One is data members and another is function members. Let us also have a function in it. Let me keep a message function which does not return anything, so its data return type is void, and it does not have any arguments. Sorry, it prints a message only. Okay, so I have defined a function within the structure. Now I can say cout HELLO. Okay, once I compile it, you see it works. You compile, it works. Okay, now this is allowed. Okay, so I have created a class employee, same way I created the structure. In the structure I give the keyword struct, but in a class I give a keyword class. Now structure had both data members and function members in C++. Same way our class can have data members and function members. Okay, then I created a variable of type structure. Same way I created a variable of type class. Okay, but the variable of a type class is called as object. Okay, this is the first one, that is same steps are required for using a structure and class. That is, first we define a class, then we create a variable of the class, and next is we access the class members. Okay, these steps were required for the structure also. Now except for creating the class, we use a word keyword class instead of struct. Okay, we use a keyword class instead of struct, and we call it as an object. We call the variable of a class as an object instead of class variable. We don't call it as a class variable, we call it as an object. For the structure variable, we call it as a structure variable, but for the class variable, we don't call it as a class variable, we call it as an object. So what is an object? We say object is an instance of a class. Okay, actually the concept is same. It is again a variable. It has got the data member same as structure. Now the important difference that is between the structure and the class is this one. Let us see that. We have seen that in a class, in a structure, we could access the members within the main. That we have seen. Let us try to access the members within a main for a class. Now E1 has got how many members? It has got a name, it has got a employee ID and message. Let me access employee ID and message. How do we access? We use the name of a variable, that is E1 dot, what is the name of the member? Let us see that is EID. I say E1 dot EID equal to say 12. Now I am accessing this. Why? Because I am using an assignment statement. Now if I say E1 dot message within the main, who is accessing? Main is accessing. I have made it clear because we can use assignment statements or function calls or input output statements within the function only. So call to the function can be made within the function. Assignment statement can be used only within a function, and this input output statements can be used within a function. Loops can be used within a function. Conditional statements can be used within a function, and declarative statements can be used within the function and outside the function. Unconditional statements can be used only within a function. So outside the function we can use declarative statements as well as within, but all the other statements that are available in C except declarative statements have to be used within the function. So function call again can be used only within a function body. Within a function means function body. So within the function body of the main, I am trying to access employee ID and I am trying to access employee ID and message, and these two are the members of a class, that is employee. I showed you class is same as structure, with the difference that we create structure with a keyword struct, but a class we create with a keyword class. And classes are also again user defined data types or abstract data types, or what we call as templates. Now first step is defining the class, second step is creating the variables of the class, and third step is accessing the members of the class. We are accessing the two members of the class, AID and message. Okay, we could have also accessed the what you call name with gets. You can use that also. We'll see gets, that is e1 dot name. Okay, this is how we input character arrays using gets. And now let us compile and see what happens. If we compile, you see there are errors. What are errors? Employee name is not accessible, employee ID is not accessible, and employee message is not accessible. No, that means the members of the class. But if I say members of a class or a member of a structure, it means both data members and function members. So members of a class are not accessible by default, so their access specifier is private, or their visibility is private. Okay, what I mean by private and protected, it has got again a detailed meaning, and as I move with the concepts I can explain it, but right now you understand it like this, that private and protected members cannot be accessed. By accessing I mean they cannot be input, or they cannot be output, or they cannot be used in assignment statements. Equally for functions, they cannot be called, or they cannot be called, yes, or they cannot be used. Okay, so we have seen there are errors in accessing these data and function members of a class. So we have told you by default the access specifier for the class is private, and for the structure it is public. We have seen that earlier we created structures and we could access its members without writing an access specifier, but now if I write an access specifier as public here, you will see we will be able to access the members. So we have three types of access specifiers for all the members of a class, that is they are either public, or they are private, or they are protected, but by default they are private, and for structure by default all the members are public. Let us see what happens because of the public, and if you compile it, you see there are errors. Let us see, there is some error here. Oh, I have not given the correct keyword, public. Okay, compile, it is a success. Now we can access. When we did not write a public keyword, it was evident that we could not access the members of a class through its object. Now E1 is not said to be the class variable, it is a object, whereas S1 is a structure variable and S2 are a structure variable, because student is a structure. How it is a structure? Because we have created it with a keyword structure. Okay, now we have created this with a keyword class. The only differences are these differences only, otherwise the concept is same. Okay, the class has the data and function members, structure has data and function members. Class we create with a keyword class, but structure we create with a keyword structure. In class the default access specifier is private, but in a struct the default access specifier is public. We can change that, okay, by using access specifiers. As I told you, access specifiers or visibility is of three types, of a member is of three types, that is public, private, or protected. Okay, now the class variables are called as objects, and structure variables are called as structure variables also. only. Okay, they are not called as objects. Okay, so class applies the class. Once we say class, we use the concepts called as object oriented concepts. Okay, so the same steps are required for using a structure and class, except there are three differences now. Structure we create with a keyword struct, and class we create with a keyword class. The default access specifiers of all the structure members is public, but the default access specifier of all the class members is private. Of course, we can change that. Then the once we declare a variable of type structure, we call it as a structure variable. But once we declare a variable of a class, we don't call it as a class variable. We call it as an object, and object is defined as an instance of a class. Okay, but memory, so far as memory considerations are concerned, or the way we treated the structure variable, same way you can treat the object. Okay, now these are the basic differences, and now we have moved into what we call as object oriented concepts, and we have seen two concepts today again, that within a class and within the structure we can have what we call data as well as functions, data members as well as function members. So that is, we can have a code and data within the same code block, and this is called as data encapsulation. Second thing, we have seen that we can restrict the access of the data and functions by using access specifiers, and this is called as data hiding. These are the two important features of object oriented programming, that is data hiding and data encapsulation. We will see some more features later, and I hope you have enjoyed the today's class. Thank you for being with me.